So at this point, make sure you go to Canvas and go underneath the module that says syllabus and notes and download. It'll say derivatives and integrals master. So go ahead and get that downloaded because you're going to need it. All right, so that being said, is this stuff can get pretty intense if we do it, especially if we start doing fractions and all that kind of mess. So there's a shortcut. So instead of teaching you the entire section, and then teaching you the shortcut, we're just going to dive straight into the shortcut. So this was the original problem. Yes, this is where we stopped off on the last video. And then this was the derivative. So here's your little hint. If you take your exponent and drop it in front and multiply, then drop your exponent by 1. Okay? So drop the 2 out front, drop your exponent from a 2 to a 1 that I'm too lazy to write. Okay? And then do the same thing with this. Drop your exponent out front, and then you'll be left with an x to the 0, and any number to the 0 power is 1. Okay? And since any number to the 0 power is 1, I can drop the 0 out front, and that goes away. So every constant has a derivative of 0. Now be careful, because this is a coefficient. This is a constant multiple. So if I wanted to take this thing's derivative, I would drop my exponent out front, so it would be a 2. And then I would have x to the 0, and then this derivative would be 0. Okay? So now let's explain how to read this. We're going to zoom in. All right, so what this means is take the derivative, and the variables that you're messing with are x's. Okay, so this is d dx. And it means take a derivative in terms of x. And what this means is I have a c, which is going to be some number, times an expression that contains a variable. And that's going to equal c times the derivative of the expression containing the variable. All this means is that your coefficients come along for the ride. Okay? This simply means that you're going to go term by term. So if I'm taking the derivative of a multi-term expression, I can take the derivative of the first term plus or minus the derivative of the second term, and that's exactly what we did here. Okay? This we're going to get to in a later one. This we'll get to in a later one. And this is what I just told you. The derivative of any constant by itself is 0. And then this is kind of sort of convoluted, but this is what I was talking about dropping your exponent out front. If you have a u to the n, the derivative, to take the derivative, you're going to drop the exponent out front, which is why the n is out front, times u to the drop your exponent by 1, and then times the derivative of whatever your variable was. Okay, so this is power rule. So when I talk about power rule, that's what I'm talking about. And then the derivative of any variable to the first power is just 1. Okay, so the rest of this stuff you'll learn later on, but it goes on and on and on and on and on. And I would be diligent. This is one of those things you're going to end up taking derivatives so often that you don't have to reference this a lot. But there are some institutions, find out where you're going, because they may expect you to know this by, off the top of your head. You may not be able to use this. In my class, you can, but it's up to you to find out if you need to memorize it or not for future classes. And then the last thing is, hang on, I don't remember the last thing. No, I don't remember the last thing. So whatever, here we go. All right, so if we are going to, I've lost my paper. Okay, so we did this one, we did this one. All right, so this says using the limit process. Unless I'm staring at you through your dining room window, which is awfully creepy, I'm not going to know what process you're using. Okay, so I'm going to go ahead and dive in and just use the shortcut, which is the derivatives and integral sheet. So that being said, the derivative, which is f prime of x, is going to equal, well, what's the derivative of 4? It's going to be 0 because it's a constant. So what's the derivative of a negative x squared? Drop your 2 out front, okay, x, and then drop your exponent by 1, so that becomes to the first. So just don't bother writing the 1. And that's it. So we save a whole lot of time by doing the shortcuts. All right. So now we just have to get into some, let's remember how to work algebra stuff. So this time I've got variables in the denominator. And that immediately should send up some red flags for you. I better fix it somehow. So I'm going to bring up my denominator using a negative exponent. So remember, right now my denominator is raised to the first power, because I can raise anything to the first power. And I'm going to bring it up top by changing the sign on the exponent. So that negative actually says, hey, whatever I'm attached to, I belong in the opposite part of the fraction. But so that's why it's an x minus 7 to the positive 1 in the denominator, but it's a negative 1 in the numerator. All right, so now it's set up to where I can do this. So I'm just going to use power rule. So drop your exponent out front times what's sitting there, and then drop your exponent by 1. So when I say drop it by 1, you're going left on the number line. So don't make this be a 0, okay? So negative 1 minus 1 is negative 2, okay? You can also leave it like this. But again, if you're going into Cal 2, if you're going to UTA, anything like that, they're going to expect you to fix this back and make it simplified. In my head, this is simplified just fine. But what would that mean? That means negative 9 is in my numerator, because it's over 1. And that would mean x minus 7 to the negative 2 will be x minus 7 to the positive 2 in your denominator. WebAssign will take it this way. You may need to learn how to do it that way. Okay, but for my class, you can leave it like this. Let's do some more. All right, so I've got a 6 over x squared. So what's my danger? I know that I'm in, I need to bring that exponent up top, or that variable up top. So I've got a 6x. I brought it up top, so it's negative 2. All I've done is algebra. I've not done calculus. So now take a derivative. So drop your exponent out front, drop your exponent by 1, and then you're done. So if you were to rewrite this, it would be negative 12 over x to the positive 3. Okay. All right, so this one, oh no, I have a root. All right, so I've got an x plus 4 raised to the first power, but I am taking a square root. So your index in that little check mark spot, okay, is a 2. And what I need to do is change this into what we call a rational, which means fraction, exponent. So I've got an x plus 4 to the first, and I'm going to change it to an x plus 4 to the first, but I'm taking a square root. Okay, so now math people cannot manipulate symbols, but I can manipulate numbers all day long. Okay, so now it's in the proper format for me to take a derivative. So drop your exponent out front. X plus 4 to the drop your exponent by 1. So 1/2 minus 1 is negative 1/2. And if you were to rewrite this, I'm not going to do this on every problem. Okay, I've got a 1 in my numerator, I got a 2 in my denominator, and I've got an x plus 4 in the denominator, and it's a square root. Okay, so either way, WebAssign will take it either way. So consider the following function. Find an equation of the tangent line. So all I've been doing so far is finding the formula for slope. I need to take this one all the way through. So what do I know? I know that this is a parabola. It's an x squared plus 3, which means he's a parabola that's been shifted up 3 units. And the point that I'm interested in that's on the parabola is 1, 4. So first of all, let's find the right one. This is an upside down parabola. It's not him. This is right side up, but it's at the wrong point. It shares the point negative 1, 4, so that's not it. Upside down, this must be the right one. So you got a right side up parabola, and the tangent line and the parabola share the point 1, 4. So this is the correct picture. Now we just got to figure it out. So what does this say? Find the formula of the tangent line. So what do I need in order to write the equation of a line? I need to know what my slope is, and I need to know what my y-intercept is. Well, slope is now going to be determined by the derivative. Okay, so first thing, take your function. What is his derivative? Drop your 2 out front. So I get a 2x to the first that I'm too lazy to write. And then the derivative of your constant is 0. So this is your derivative. This is your formula for slope. So what is your slope? Well, if I'm interested in the point 1, 4, then I'm going to substitute in the x of 1. So 2 times 1 is 2. Okay, so my slope of this tangent line is 2. Now, if my slope is 2, and if the point I'm worried about is a 1, 4, now I'm just back in algebra world. Calculus is done. I just got to find the equation of the line. So I know that this is an x and this is a y, but I need to know what b is. Sorry. I need to know what b is. So my y is 4, my m is 2, my x is 1, and I need to know what b is. Okay? So subtract 2 from both sides, so I get b is 2. So the equation of my tangent line is this. I have y equals m. What was your slope at that singular point? The slope at that singular point is 2. And where does he cross the y-axis at? He crosses the y-axis at positive 2. So if we look at this, that should make sense because he's crossing the y-axis at positive 2. And then if you count it off, you're going to find out that the point 1, 4 is right there-ish in there. So that's your equation of your tangent line. Okay? So let's do some more. I'm trying to squish this into one video. So I have a function. Okay, whatever. We have a function that's x squared. Okay, I need to find an equation of the line that's tangent to the graph of this, but it's parallel to this line. So what on God's green earth does that mean? What I have is a parabola, okay? And I also have the graph of the line. If I add y to both sides, that'll be a y equals 4x plus 4. So there's this pretty steep line that's coming this way. And what I would like to do is find a line that's parallel to this, but tangent to this. So first things first, what do you know about parallel lines? They have the same slope. Okay, so I already know what my slope needs to be. Okay, I already know what my slope needs to be. So here's what we're going to do. Go to your function, find the formula for slope. So drop your exponent out front. And then say, well, what do I need this slope, this formula for slope to equal? I need him to equal 4. And that will occur at an x value of 2. Okay, divide both sides by 2. That will occur at an x value of 2. So far, I've got 2 of my 3 pieces that I need to find the equation of the line. So what I've got is an x value of 2. I have an m of 4. Well, I need to know a y value because I need to have a point and the slope to make the equation of the line. Well, if I know that this has an x value of 2, what point is on this graph? If I shove in a 2, 2 squared is 4. So I know that 2, 4 is on this graph. Okay, so now I just need to know the equation of the line. I have the m, I have the x, I have the y, and I can go from there. So 4 equals slope times x plus b. So subtract 8, and we found out that our b is negative 4. So to round this thing out, my slope is 4. It's parallel to this one. X, and then where does this thing slice through the y-axis at? It slices through the y-axis at negative 4. So the equation of this line is 4x minus 4. All right. Okay, so I'm gonna start over. There's only a few more, but I was trying to avoid 2 videos, but we're not gonna work.